The next one is from David Aronchick from Expanso. There you are.
All right. This was also designed to be a very long talk, so I have to cut it down a lot. So a lot of people, most of the things you've heard tonight have been very focused on building your ML models, and those are fantastic. Don't get me wrong. But the question is now that you have your model, now what? And the standard is something like this, where you have your developer, and she says, "Look, the model looks great. Let's roll it out." And piece of cake here, you take it, and the SRE says, GFY. And the reason is because rolling out models is incredibly hard, right? These are just a small set of the things that will go wrong when you roll your model out. I guarantee it. These are all real world examples that I have seen and navigated customers through, where it just doesn't work at all for no reason that you can figure out. And so you're saying, fine, okay, maybe it's because, you have this like very complicated deployment. What if you just instead do some giant machine and a giant data lake, right? That'll solve all your problems. Nope, doesn't solve your problems. Not only is it still hard, like you have the same problems you had before, but now you're getting to on top of maintaining a data lake, right? Which, before you move your data, you have a whole bunch of problems. After you move your data, you have a whole bunch of problems. Like, it's just not easy. And people never think about this. They're just like, well, the model's done. It's ready to roll out. And you might say, you're very smart. And when in doubt, use bash, right? How hard could it be? That's the script that actually works and rolls out your model to all these like various VMs that you have in line. Except, what if you have any of the problems that you normally run into when it comes to distributed systems? Bad networks, unreliable networks, always once delivery, so on and so forth. How do you do all these things atomically? And the question is like, why? Why is this so hard? And it's, in a lot of ways, it's because distributed systems are hard, but you can't centralize a lot of this stuff. The reality is data is growing everywhere. Not in, very inconveniently, it's not growing in some data center in Oregon. It's growing everywhere there is a compute device, from your temperature sensors to your multi-region cloud to whatever it might be in the middle. And you say, okay, that's a lot. And that's where we come up with an architecture called compute over data. Now, when we were working on this, we kept abbreviating it COD, C-O-D. So that's our logo, a little funny fish. And we happened to have been in Portugal when we were coming up with it. And that's why we built a project called Bacalhau, which means COD in Portuguese. And the idea is that Bacalhau is designed to solve for these problems, both at the data layer and the model layer. It helps you transform your data before you move it, executes over poor networking, helps you use data in isolation. This is what a Bacalhau job looks like, and I'll show you this live in just a second. The project's been out for about 2 years. We're open source, but it is very straightforward. If you know Kubernetes, you know Docker, you know YAML, it's very easy to roll out. It helps you significantly reduce the challenges of transforming your data before you move it, including saving an enormous amount of money on things like logs and processing and things like that. It improves executing those jobs over distributed networks, meaning you don't have to go out and learn 45 years of distributed computing knowledge before you get going, and helps you process those jobs in place. So if you're in any kind of regulated industry, healthcare, manufacturing, FinServ, so on and so forth, you're able to execute in the region where those regulations are, rather than first moving it to a lake and taking on all that challenge around that. And it helps you roll out your models exactly where your data and likely your users are. So here, for example, you have your single developer. She grabs her model. She hands it to the Bacalhau network. You'll have a small agent running anywhere you want to deploy something. She rolls it out to all these machines, and off she goes. And then when she's ready to update, she can use the same command to move that out globally. It wouldn't be a, what do you call it, unless there was a demo? Lightning Talk, unless there was a demo. And to show you what a container or what a job looks like, this is actually a live container or a live job right here. Very, very straightforward. This is just going to be a stress container. So it's going to run across all these things. And just to make it harder on myself, right now we have this deployed across 37 different machines, which happen to be on GCP and Azure and AWS, like all of them, one command to deploy that very job all I do is Bakuya job run, and then that command, and then off it goes, right? So right now, this is all real and live and happening as we speak. It's taking this job, it's creating it for submission, and then it's running it right now across all 37 machines, across every cloud. That's it. There's nothing special. Setting this up is lightning quick. It is a single job. Now, this is going to take about 60 seconds, so I'm actually going to cancel it. It's a stress job, so it's actually out there pegging the machine right now as we speak. But I said earlier that using stuff like this makes it much easier to do things like update my jobs and containers in all those locations. Again, this isn't me doing a bash script against all those places. Now I'm going and executing that same job, but on the new machine, it is stopping the previous one at a time, atomically, and starting the new one in place. And again, that's because that's what I told it to do. It could start it up in parallel and then swap it over, so on and so forth. That's all in flight. And like I said, just looking at the job, you can see it's deployed to all of those various machines spread all over the world. I have another demo here. You can see each one of those accepted the job. You can see it. We have a rich API. And again, there's nothing wrong with Bash. I use Bash every day, right? Or cron or anything like that. But where's your API? Where's your introspection? Where's your observability? That's all hard. You can do it, but why? Why not use a distributed computing system that is built to solve these problems? And let me steal some of Luke's thunder here. So one thing, this was all these machines that were deployed here. I meant to show you that earlier. All right. So to steal a little bit of Luke's thunder earlier that he'll be showing in just a second, again, all I showed earlier was a stress container. What if I actually ran an ML job, right? And so now what you're going to see me do is use the Helix CLI, which Luke will go into in some depth in just a moment. On each machine, it will grab local information, upload it to a common or to the Helix API in the cloud, and then automatically update that update the store so that you can run processing over it. So in this case, or you can run NLP against it. So here we are. Off I go, and I'm going to say, where are my Helix job? Bakuya job run, and then I already had the, did it work? Oh, I'm in the wrong directory, sorry. Here. Here, I'm gonna run the Helix job, and just to show you what that's doing behind the scenes, here it's loading, it's going via bash, it's grabbing the CPU info from every one of those machines, and uploading it using the Helix CLI to the Helix API cloud. Using here, I've mounted the environment directory, very, very secure to, by the way, build your API key into your job. Please do that. But regardless, it's doing that, and behind the scenes, Helix is automatically indexing this and allowing me to do a query. So now when I go over here and I pop out, and I go to the Helix API, you can see here every host name has uploaded this to the Helix store in the cloud. If I click on one, I can see the CPU info from that particular machine. And here I can say, what is the speed of the CPU? And when it does it, there you go. Right? So that was a natural language query done live against data that had just been updated from machines all over the world. That's the power of the distributed system and what you're going to see shortly with Helix. And I am almost done, I promise. I don't know where my time is. We are open source. We're backed by a commercial company, Expanso, but the project is open source. Please come, please join. We believe very, very strongly in open source, and we would love to help people develop a brand new way of deploying software.